Greetings everybody, welcome to part 9 of my engine build. Today is going to be about the camshaft, and we're kind of moving on up from the bottom level to the middles, and then eventually we'll be at the top end. Just keep adding parts to this thing. So I'm going to get the camshaft installed today, going to get the timing set installed, I'm going to do some side things. I want to measure the piston height, the deck against the deck height to find out what my volume is there accurately. The machine shop told me they had taken some 7,000 or 8,000 off of it, but you can't really go off that on the factory spec because some of these blocks, I understand, were as much as 9,030 on the deck height, even though spec was 925. It just depends on the casting and how much they had to machine off after it was forged. So I'm going to go ahead and get TDC with my dial gauge and then measure the difference between the deck height and the top of the piston. Make sure I keep that number logged down. Got some parts in, just acquiring things here and there. We're kind of getting on the smaller things, the little cheaper things that you have to get for the motor before you go after the next big stab at it, which is going to be buying the cylinder heads and intake. Go ahead and show you what I got for the parts, the cam, and the other things I've got right here that are either installed or ready to be installed. Here's the camshaft I'm putting in. I told you in the other video I got the Lunati bare bones cam. This is kind of a, you call it a stage 2 cam, maybe just a little bit better than stage 2 because I'm going to run 1.6 rockers with it. Excuse me, get a little more lift out of it. With the rockers I'm using, I'll get somewhere in the 470s intake, 490s exhaust on lift. The duration on this was advertised at 280 something intake, 291 I think exhaust, and the at 50 lift was 215 and 224 I believe. So that puts it, like I said, about a stage 2, 2.5 over a factory cam. It's got the lobe separation angle on this is 112 degrees and the center line is 107. With that LSA, the engine should still have a fairly smooth idle, but be just on the edge of lopey. I mean, I want a little bit of sound out of it, but I also want to be able to make vacuum to run the brakes and everything. So this is kind of teetering on the edge, just about as far as you can go with that and not cross over to the part where you're going to start getting lopey idle and lose vacuum at idle. Maybe have to run a vacuum pump, which is parasitic, and that defeats the purpose of having a more powerful cam. But anyway, so that's the camshaft. I did get new lifters. I said in the video before that with the lifter bore clearancing I had to do, I was not going to use the same lifters. So I got 2 new lifters from Lunati. I'm not going to use the one that I test fitted all the bores with, or the one obviously that I used to clean out the bores. So I got 2 brand new lifters for that. Other parts I got the oil pump in. This is the Summit Racing high volume standard pressure oil pump. And I've got the pickup, the intermediate shaft installed on it right there. As you can see there, I am running a copper gasket. Don't know if I'm going to leave that in there or not, or go with a film of anaerobic sealer, like that red sealer they used at the factory. I don't want to run metal to metal. I just don't trust it, even though everybody says it's fine. I want to have something to take up the irregularities or any gaps in those mating surfaces. So there's going to be some kind of seal there on the oil pump. I've got the oil pump adapter coming along with the oil pump pickup tube. They should be in by the end of the week, so that part of the lower end will be taken care of. So we can seal it up with that. There's the oil pan. That's another Summit Racing product. This is the 7.5 inch deep 5-quart oil pan. Did not come painted, obviously. It came in bare metal and I had to use the same paints, the VHT primer and VHT Chevy orange on it. Looks fantastic. And I got the one-piece Velcro good oil pan gasket because I've tried sealing before, just with those 4-piece units, that's the side rails and the front and back, and the little moon-shaped gaskets for the timing cover in the back. Man, those are such a pain in the ass to get straight when you're dealing with 4 pieces shifting all the time. So I spent a little extra money and got the good Velcro gasket for that. I don't want to hassle with that stuff. It's kind of it on the new parts and the ones that are on the way. So we're down to getting to put in the cam. I did put some assembly lube already in the cam bore and on the, I guess I should say, the cam bearings. I wish these motors were like Chrysler's, where they had an open top of the block and they used a valley pan instead of the cast iron lifter valley like a Chevy block, because on the Chryslers you can get your hand down there and you can actually lube each individual bearing up, and it's much easier to guide the cam through. But I don't have that. I got a Chevy. They didn't do it that way. So what I did is I took one of my cleaning brushes and globbed some assembly lube on it and went back to front trying to get some lube on each of the cam bearings, because you can lube up the cam as you go, but each passage it goes through, it's going to wipe more and more of that lube off. So by the time you get to that back one, there isn't going to be much left on it. So you've got to put some kind of assembly lube on them as you go before you get the cam installed. That's been done. So for all intents and purposes, I'm ready to go ahead and start installing the cam, and that's what's going to happen in the next part of the video. Okay, I'm going to go ahead and get the cam installed. As I mentioned, I have assembly lube on the cam bearings already, and I've got my lobe lube that Lunati sent that you have to use for that. So to start, I'm going to save most of the Lunati stuff for the actual lobes and just use assembly lube on the bearings. Just lubed up as you go. I try to keep this as straight as possible so you save what's on there. You better get a little towel to stay in the motor as you go. Definitely want to get some on these gears for this would be the gear for the oil pump here. Definitely want to lube that up. Got that. We'll start putting some of this assembly grease for the lobes on. Just rub it all around. Make sure she's coated really good. Just looking to make sure there's no dry spots on any of that. It's amazing the different viscosities and formulas for assembly lube. I've got 4 different kinds now of assembly lube in this motor. Each one has I think works differently for a different side of the motor. Like I use that red Loctite Ultra Slick for the lower end, and I'm using this Stay Lube for the cam, and I'm using this stuff from Lunati for the lifter parts. I'm going to spread this out slowly at first because I want to make sure I have enough in this package to cover everything, and then whatever's left is going to all go onto it. But I want to make sure I have enough to cover, give it an even coat of the whole can first. Then I'll put whatever's left on it. All right, so that's the first half of the cam. I think I can go ahead and get her started in there. She's lubed up to the second set of lobes. Now I do have the 2 bolts. Went to the hardware store and got the bolts. These are 5/16 with 18 pitch threads for that, and they match. I just took the cam bolt that came with the that I had to buy up to the hardware store and matched that bolt up. Got these long stainless steel ones to help hold it as I put it in. So I'm going to get it in and rest it on the second lobe. Go slow. Just find each lobe as you go there. All right, I've got that in. Now I'm going to lube up the rest of it. I know this is so exciting on film, right? Just watching somebody grease up a shaft. Yeah, insert joke here, I get it. All right, get these lobes lubed up here. And I mentioned the 4th kind of lube. Well, that's just engine oil. Part I used in the cylinders. So 40 weight non-detergent. The reason I use non-detergent is I don't want any detergents in, even the residue with the little bit of oil that's been used in the motor so far, just as a
passive lubricant for assembly. I don't want any detergents in this motor because those will separate out and bind to the zinc particles in your break-in oil, and you won't have break-in oil and you will burn up this cam really quick. So I'm not going to use any detergent oils probably ever in it, to be honest with you. I mean, if I do, they'll be mild detergent or I'll use an additive, but we'll see. The way this is going together with the tolerances I have, it's kind of like I would think I'd be able to use 10W30 in it all season. I won't have to run, I don't want to run a real thin oil like a 530, even though that helps with horsepower. There's less drag on it. Just never been a fan of, even though the new motors come with like 520, even for V8s, they're like 520, something like that. I just think that's too thin. I know they run super tight tolerances. Modern machining is just so much more accurate and predictable than it used to be. So they know their tolerances are good and it doesn't have to be taken up with oil. The difference, the slop. I just don't trust oil that thin in a V8. I mean, I run 530 in my V6s and 4-cylinders all day long, but not in a V8. All right, that's pretty much all the lube from Lunati on the cam. Get this last bearing lubed up and ready to go back. We're almost done with this. All right, so we're going to slide this in the rest of the way. One more to go. There she is. She is in. We'll use this lube to hit these thrust surfaces for the timing chain. Something that gets missed is the back face of your timing chain gear and the front face of the motor. There's a machine surface here and it needs lube on startup or you're gonna get metal shavings. So just use whatever lube squishes out. When you do this, give this a little work back and make sure the lube is spread out evenly on all the cam bearings. It's got a nice tight feel to it, so I know there's a good amount of lube on it and I don't hear any grinding. But anyway, you'll use what squishes out and just hit this machine surface here with your lube. All right, so get these bolts out and then we can roll it over and do the timing chain. Okay, ready to start hitting the timing chain. First thing I want to do is roll my first piston to TDC. And right now you can't tell if that's going to be an exhaust or intake stroke, and that is all determined by the distributor, not the position of the cam. But your keyway on a Chevy is going to be like at if you go 45 degrees, it'll be pointing at the #1 piston at TDC. And this is just a rough estimate. I'm just watching the piston move up until it stops, and I'm going to walk it back a little, figure out how much dwell I got. About right there. So it's kind of pointing right at piston 1. And then your timing marks on your gears are going to be dot to dot. That's installing your cam straight up. There are timing sets you can get that can give you an advanced or a retard built into the timing statically. You'll never change it. It'll be there all the time. And that helps give you more throw with your distributor. Like if you're running high boost, you got to run really retarded timing. So your distributor throw may not be enough to give you that much of it. So you install your cam for 8 degrees retarded to begin with, and that makes up the difference, which you can't get with your distributor. Anyway, so I'm using this Cloy's double roller timing chain set. It was a value proposition, but Cloy's is a known brand, and I'm going to trust them. So let's get these parts out here. Got the crank sprocket here, and there's the triangle right here for straight up timing. And gosh, I just wish you could see, but there are actually marks on this. There's 3 different positions for the cam, or I'm sorry, for the Woodruff key here, and that would be your difference in stalling timing straight up versus retarded or advanced. But I'm going with straight up, so I want this triangle right at up. It's on there. My piston's at TDC. Okay, I'm going to just stop right there. Things started to go off the rails for me a little bit at this point in the video. First off, I was talking about the timing marks, and I said there was a triangle and a dot, but I was talking dot to dot. Keep your references the same. There is a dot on the lower crank sprocket. The triangle is for advanced, the square is for retard on this cloise set. So I got that figured out before I got too far in this. No big deal. I caught it, is the point. But what happened was, after I got this timing chain on, I didn't, and I've put timing chains on before, many cars. Started with my dad in the driveway when I was like 7 or 8 years old, helping him do it on an old Chevy Caprice with a 400 in it. You got to press the damn timing, the crank gear on the Chevys. They don't just slide on. So I didn't remember that, and I got this put on. It stopped on the key. I'm like, okay, it's set in there. Then I put the cam sprocket on, got the dots lined up, got the chain set up, started putting my bolts in, and as I'm tightening the bolts, I'm noticing the cam walk forward out of the bore, out of the cam journal. Not cool and not right, obviously. So that was a big tell right there. So I had to step back, scratch head, step back forward smarter. So that's when it dawned on me. It's like, oh man, this crank sprocket is not pushed back far enough. Well, how do you do that? Well, I started thinking, I was like, okay, well, how do you get anything metal, you know, with tolerances to clear? You heat it up. So I went ahead and I got my propane torch out, and I lightly heated the crank sprocket all the way around. I just kept moving it around as I went. And then I re-offered it to the crank nose, and it went in further than it did before, but not far enough. So then I got like a drift setup, and I just started tapping it back slowly, evenly spaced, even number of hits, walked it back with the drift until I got it kind of like the tone to change on it. I feel like it's home, and it lines up now with the crank sprocket. So my cam sprocket, crank sprocket are lined up now, not just dot to dot, but face to face. So that's done. The cam sprocket went on much easier after I did that. It wasn't tilted out like this. So the bolts lined up clean. Got those Loctited and torqued down, 20 pounds. Everything's lined up. Rotated the engine. As I rotated the engine about, 40 degrees at a time or so, I started offering oil up to the chain from my squirt can until I got oil all the way around it. So the chain is nice and oiled now. The sprocket teeth are oiled. This is done. But I told you in the engine build video where I put the pistons in, this is my first time doing this as a whole. And it's been a long time since I've done any of it as a part. So I'm remembering things and I'm making mistakes along the way. And I told you I wasn't going to delete any of them. Well, I didn't. I'm telling you now how I screwed this up. It was so bad that the cam was walked out from these bolts to line up with the lower sprocket so much that it dang near fell out of the back bore or the back journal. If I had let that go, big screw up, big time. I've thrown the chain at worst, or at best, and at worst run out my cam and ruined it. So, but I'm confident now that the timing chain is on straight and correctly. So the next thing I'm going to do in this part of the video, just the last thing I'll do with this one tonight, is I'm going to go ahead and get my bore gauge and my magnet mount set up, and I'm going to measure my piston height as referenced off the deck, so I know how much surface area, how much volume I'll have from that in the piston, so I can do my final calculations. All right, well, the question is, how do you measure your deck height against your piston? This measurement's important because it's part of the compression ratio calculation. The entire diameter of the cylinder bore plus or multiplied by the verticality of the piston in the bore minus the deck height gives you the volume of the cylinder. You add that to the head gasket thickness and the cylinder head port volume, and that gives you a lot of your volume calculation for your compression ratio. So to do this with a dial bore gauge, the best way to do it is with a bridge that's equal height and covers the piston with 2 slots for 2 dial bore gauges. And that way you know that the height stays the same as you move the gauge around. You reference it first to the deck height. You'll zero it out. So right here I got the bore gauge. I don't know if you can see it, but you'd put it on there and you'd hit 0, or you'd roll your ring to 0. Then you would rotate the bridge across the deck at the wrist pin, take the measurement here at 3 and 9, because the piston, it's on a swivel because of the wrist pin, so it's going to be higher at the one end or the other in this axis, but should be even across the wrist pin. So that's the reference point you want to use. I don't have the setup to do it with 2 dial bore gauges. I don't have the bridge, so I'm going to show you the dirty method that I thought of to do this, and that's simply using feeler gauges. If you have a good straight edge, that helps. I looked around and I really don't have a good straight edge, but what I'm going to do is I'm just going to take my feeler gauges and I'm going to kind of eyeball this cylinder as I rotate it to where I see it stop moving up and dwell for a moment, and that's pretty much as high as it's going to get. I'm going to start with a set number. I got my 21 thousandths feeler gauge. I'm going to lay it across the top of the piston, and I'm just going to rub my finger in one direction or the other and see if I feel a lip. I still feel a lip at 21 thousandths right there, so it's at least that much. Let's go up to 22. Still just the slightest little bit of a lip, so we'll go up to 23. And you keep doing this until you find out which one lies flat against the deck and the piston. And that is going to be your deck height. There's 23. That feels nice and flat. So I'm going to go with 23 there. Measure it on the other side just for kicks. Still feels pretty darn flat. So I'm going to 23 thousandths is the number I'm going to use on one. But you got to take this at all 4 corners. So you're going to do 1, 2, 8, and 7. So now I'm going to rotate. I'll do 7. Roll it around till it comes up to about the top. Watch for the dwell. Just move down a little bit there. So right there is going to be the height. I'm going to start with my 23 again. Measure it out on this cylinder. 23 is a little low, so I'm just going to move the piston a little bit and see if maybe I can get a little more lift out of it. The wrong way. Try it right there. Yeah, there's a little bit left in it, so it's within a thou. So I'm going to call that 23 thousandths. We'll go over and do piston, well, which one's on its way up right now? Number 2 is on its way up, so we'll bring 2 up to its highest point. Right there. Sticking with the 23. Feels like the 23 did there, a little low, so maybe 24 on one side. The other side, yeah, it's probably closer to 24. But when you're talking about thousandths of an inch and eyeballing your piston travel, it's certainly close enough. Do it again. Actually, now that I reset it, 23 feels better. So this one's 23 also. Go down to cylinder 8. Bring it up. Let's see what we get. Perfect, 23. So, my cylinder height is 23 thousandths. That's what I'm going to use when I go back to the compression ratio calculators and redo this. This is the first time I've measured it since I got it back from the machine shop. Now, the machine shop said he took 7/8 thousandths off. Factory spec for a Chevy small block is 9025 on the height, which means if he took 7 thousandths off and I'm at 23 or 8 thousandths, this thing was a taller deck than spec. But you know what? if you read around, that's completely normal. These things all don't come out of the factory mirrored imaged of each other. It's certainly not completely true to the original design specs. Differences in casting, the day, the temperature, how much they had to take off the head to get it smooth will all affect the deck height of the block. And you can't just say it's 9025 because that's what the engineers wanted it to be. The reality is the number you get. And mine after decking is at 23 on the cylinder height. Now, difference too is the pistons. These are not the factory pistons. The factory pistons may have been a little bit taller than these are. I don't know. But these are the pistons I'm using. So it's all relative. Everything has to be measured off of what you're actually going to use, not off of spec book. Reference the spec book, especially things like bearing clearances. But when it comes to something like this, it is what it is, as they say. So 23 thou, that's what my piston to deck height is. Been a weird day on the engine today. You know, I had another challenge, another, not setback, but another obstacle to overcome, and that is, again, my inexperience. But I got through it, and that's the way we're going to continue on with this. I am not stopping. We'll just take each challenge as it comes and figure out a solution, just like we did with the timing chain here today. All in all, it was a success because everything's together, nothing's broken, and I am in a position, I've got everything I wanted to accomplish today done. Next video will be in a while because I cannot do anything else till I get heads. I still have to, now that I've got the timing chain and the cam together, I need to check my valve to piston clearance. I need to degree the camshaft to make sure the one that Lunati sent me is what I actually got. And I need to measure for push rods. So outside of throwing the oil pan on when I get the oil pump pickup at the end of the week, that may be just a quick hitter, call it number 10 when that video comes out, but that'll just be assembling the oil pan and all that. Don't even know if I can do that yet because I got to get the front cover on the timing chain, and I can't do that till I get the heads. So yeah, I can't even put the oil pan on it yet. So this is it for a while. It's getting on middle of November. Thanksgiving is coming up, then Christmas. Other obligations and things to spend your time on are going to take me away from this a bit. So if you don't hear from me until after New Year's, it is not going to be a surprise. Just that's the way this plan's going. My whole thought was to get this done by this spring, have it running, tested, so that I can start shopping for the car to put it in. And I'm pretty much on track to do that. So thanks for watching. Again, if you like this, if you're enjoying my follies, like and subscribe, share it with your friends. Other than that, thanks for watching, and I will see you in the next one.